Hello! We are team number 9.
And the topic is sound.
The sound is a kind of wave that transports energy, having a need that makes them what they are. This need is a material to move through, and this material can change the way we perceive the sound.
We, the animals, the cars and other objects are moving through a space that is filled by air, a common gas inside the Earth's atmosphere. The voices of animals that are produced by the vocal cords travel through the fluid of air. Anyway, air of any type of gases are the only medium that sound has for move through.
In fact, the air is the worst fluid that the sound can move through because of the great distance of their molecules, making the propagation of the sound way slower than any other medium. But what are those mediums?
If we want to call a friend by knocking his door with our hand, we will hear that familiar sound of knocking, knock knock knock, or toc 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 in Spanish. If our friend sticks his hand or head to the door, he will feel some vibrations produced by of knocking, which they are not more than the waves of sound traveling from the door to the bones of his head or hand. This example is a simple situation that involves the propagation of sound through solids, and is for far the media that gives the best movement for waves thanks to the almost null distance between particles of most solids, making sound move through with the best velocity from all others.
But we have to consider the material of the solid, because each one has different properties that can make easy the transportation of the sound. But first, let's talk about the liquids. In liquids, the sound moves faster than in gases but slower than in solids because of the average distance between its molecules. And a good example to demonstrate it is the following.
Suppose that a person is swimming in a pool and you are located outside of it, and in the middle point of the distance between you, a man jumps into the water and strongly splashes in the fall. Thanks to the characteristics of water to propagate sound, the splash will be heard first by the one swimming in the pool than you. This also happens when you try to talk with someone submerged both in water. The vocal cords produce sounds and it travels faster than on air, but it distorts the wave in such a way that the receptor won't be able to hear correctly your words. Try it and you will hear the results.
So, the sound can move in solid, liquid and gases. But what could this affect the movement of the sound? This can affect the speed of the waves, like we have said this before.
The normal speed of sound in air, that is a temperature of 0 Celsius, is 330 miles per second. But it's not the same speed when we are in a hot or cool place. When the temperature increases, the speed also does in proportional way, increasing 0.6 meters per second for each 1 Celsius added.
But what temperature can affect the speed of the sound? Isn't it the same in all conditions?
Well, the temperature is measure of the average kinetic energy of the particles. So, the more temperature the system has, the faster the molecules will move.
And the faster the molecules move, the easier the propagation of waves will be. So, how much speed does sound have in some materials? Well, let's have some examples.
Until here, we have analyzed the propagation of the sound in different mediums and the relative speed of each of them. But there's something we haven't analyzed yet, and that is the sound intensity level. Any type of sound has some characteristics that define them, which is the wavelength, the frequency, and the amplitude, which determines if a sound is weak or strong. At higher amplitudes, the stronger a sound will be, and more harmful to our ear will be. Take as a sample playing a loud song in a room like this.
If we increase the volume of the cell phone, the intensity will be greater. This quantity is measured in watts per square meter in general, but the scientific community and the society itself uses a logarithmic scale that measures sound intensity, which is the decibel scale. It uses this equation and measures from the least strong sound that can be heard, which is 1 by 10 to the power of minus 12 watts per square meter, to the strongest sound the ear can hold up before it becomes deaf, which is 1 watt per square meter or 120 decibels. For now, we can say that this cell phone produces 1 by 10 to the power of minus 7 watts per square meter. If we substitute this value on the previous equation, we have that the cell phone produces a sound of 50 decibels, a normal intensity for an office or home with high index of work. Also, we can say that this cell phone produces a sound 1000 times stronger than the one by a gentle breeze or a whisper. Nowadays, there are laws that punish those establishments that produces a sound intensity louder than 65 decibels, getting apart the rock concerts and the takeoff of jets or planes that produces louder sounds than that. And they have the reasons, but let's say that sound must be regulated, to avoid any trouble that make people leave or do pain to the ear. And reflecting about this, we can say that life is matter of sound.
Video, some viewers have asked us some questions that my teammate Alejandro will answer now. So, give us the bull by the horns.
The sound can be propagated in vacuum?
In a spacewalk? No, because the sound waves need a media to propagate, and in the space we don't have the air, and the only media to propagate this sound is the solids. In this case we only have the bones, but the bones doesn't propagate the sound very well.
Why does density modify the sound speed?
If the object have more mass, it will have more disturbances, and this will block the sound's wave, reducing its speed. If the wave have more obstacles, it will be moving slower.
How can liquids propagate the sound faster than gases?
It's the same reason that in solids. The liquids have more density than the gases, which have less unit of mass per volume. The density defines the speed of sound as well as the temperature.
How can I measure the sound intensity of my music?
You just have to measure the area where your sound equipment is located and the power that it develops. Then you have to divide the power by the area, and then you will be able to substitute this value in the equation, and that's it.
Why are they called decibels?
The real unit is the bell, in honor to the scientist Alexander Graham Bell. He studied the intensity level of sound and measured it by a logarithmic scale. The reason that we use a smaller unit, that is the decibel, is that the bell is a very big unit. It's a very big scale of units.
We hope your doubts were solved with this video. We are team number 9, and here finishes our job. Adieu.